Hello everyone. In this video, I'm going to talk more about Chapter 13, Demand Forecasting Methods. This chapter is going to be covered in 2 weeks, not only week 4, but also week 5's topic is going to be Chapter 13. This is a long chapter and there are a lot of concepts to cover. That's why I wanted to plan it this way, and you will see, how rich the content is. Okay, let's get started. So in this video, I'm going to tell you more about what a good forecast is and what kind of forecasts we have. And in other videos, we are going to follow up with different types of forecasts. Okay, let's get started with what makes a good forecast, what are the good features of a good forecast. Let's talk about that. But before I do that, let me remind you one more time that this is a summary video. These are the concepts that I handpicked from your chapter 13. Please go ahead and read chapter 13 first of all, and then come back to these videos to take fully advantage of these videos. Okay. As a reminder, what a good forecast is. So a good forecast should be definitely accurate, right? I'm going to explain what these mean in a moment. It should be consistent, timely, simple, and efficient. So these are the must-haves for a good forecast. Okay, what do I mean by a good forecast being an accurate one? Well, it means that, for example, if you are shooting for the number of customers to visit your store tomorrow, and then if you are far, far off from it, let's say you expected to see like 100 customers, and all of a sudden, the real number turned out to be just 10. It's way off, right? So you expect from your forecasting method to produce reliable numbers so that you can plan yourself accordingly. That's why a good forecast should be an accurate one. Well, how do we measure accuracy? Is it just a difference between the forecasted value versus the actual value? Well, that's just a good start, but we have to do some more operations to calculate actually a forecasting error, and that's going to be the topic of week 4. Okay, a good forecast should be consistent, meaning that your forecasting method, whatever method that you're using, is giving you a good forecast, a reliable forecast with minimum error this week, and then next week it's going to be like giving you a huge deviation from your actual value. That's not really being consistent. You can't really rely on that forecasting method. Okay. It should be timely. Well, if you're shooting for a forecast for the next week and all of a sudden um, your forecasting method decided to run for a month, like if it is like a huge problem to solve, a huge mathematical problem, and you're waiting the result for it, and then it takes a month to solve, it gives you the forecast next month for next week's forecast. Well, it's actually not really timely forecasting method, right? So you really want it, before the time planning period expires, so that you would have really, a cushion period to get yourself ready for the actions. That's why you would like to have your forecast ready before actually your planning target horizon hits you in the horizon, and it has to be simple. So if it is really sophisticated forecasting method and then nobody understands what goes into it, we call it like garbage in and garbage out. That's really not something that you would like to take advantage of, because these are forecasts. These are supposed to be informative, and these are supposed to be like helpful and beneficial for your operations, so that you would understand more about your dynamics in your process, whether it's the manufacturing process or a service process. Your forecasting methods should be simple enough so that you can see what's going on with them, right? And lastly, your forecasting methods should be efficient. It shouldn't really cost you a fortune to get somebody to do the forecast for you, or it shouldn't be really time consuming for you to put everything together to get a forecast. All right, so these are good characteristics of a forecast. Um, and then the next slide is actually talking about some other further good stochastics of a forecast. These are more like, instead of being a good characteristic of a forecast, these are mostly like, the best cases for a forecasting method. So the first one tells us that the short-term forecasts tend to be more accurate than the long-term forecast. Well, this is very obvious, right? So if you are looking at your weather application, and you're looking at to see whether tonight there's going to be a rain or not, it's much more reliable compared to looking at your same weather app for the next week's weather forecast. Okay, that's pretty straightforward. And the second one is says that aggregate forecasts for groups or product families tend to be more accurate than forecasts for individual products. So this is a very important philosophy to keep in mind. Imagine that a retail store is trying to put a forecast for their entire chocolate selections. So it goes into specific brand names goes into it, right? So if you basically say chocolate bars forecast, your Hershey's, your Nestle's, your other product families go into it, right? Imagine that you are trying to make a forecast for it, and versus you are trying to make a forecast for a specific Snickers bar. Well, of course, trying to have a forecast for that specific Snickers bar is going to be much more difficult and prone to errors compared to making a forecast for the entire product family. The last best practice would be the forecast for dependent demand items are more accurate than the forecast for independent demand items. Well, first of all, what is a dependent demand item and what's an independent demand item? An independent demand item is the final actual sale of a product or service that you are offering to your customer. So it could be the finished cars, for example, that you are selling to the customer. And the dependent items for that finished car would be um, number of tires, number of engines, or number of transmissions that you are sending with that car. So if you have a forecast for the number of cars that you are selling, then you would have a forecast for the number of tires that you are going to be selling as well, right? Um, okay. There's a nice differentiation between qualitative versus quantitative forecasting methods. Usually, if you have data available, historical data available, you would like to go with quantitative methods. If you have time and the resources, you could definitely incorporate qualitative methods into it. But usually, we use qualitative methods if we don't have any historical data, or if we are, for example, launching a new product or service and we have no idea what's going to happen in the market to it, then we tend to ask experts about their opinions, or we look at our sales force and more seasoned people and then say on the field and then ask them to see what their opinions are. Or maybe we can just pay a small fee for a marketing company to do research for us. Those kind of operations can be listed under qualitative methods. In quantitative methods, we usually crunch numbers. For the sake of this course, we are going to cover naive approach, moving average, weighted moving average, and exponential smoothing method only. We are not going to be interested in these forecasting methods in this course. So whenever you are doing your reading, if you are in the subsections area, right, E, F, G, H, and I, you may just stop and then you may just focus on these four and these qualitative techniques. Okay. All right. So let's see more about two examples on qualitative forecasting methods. I like these two. So the first one is jury of executive opinion, and the other one is the Delphi method. So jury of executive opinion method is nothing really super fancy. What you do is you put subject matter of experts together, and then you ask them about their opinion, and then you just combine their expert opinions and you go with whatever comes up as a favorable approach to carry out. Um, and then the only difference between the jury of executive opinion and the Delphi method is that Delphi method, you go multiple rounds with them, right? And then in Delphi method, you say, okay, subject matter experts, I collected your opinions. X person said this, Y person indicated that, Z person said that, no, this can't be done in this way, blah, 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 blah. And then here you go, take them back and go one more round to see whether you want to change your opinion or you want to be, you want to be on the same page with X person, Y person, Z person. And then you do this multiple round until you reach a consensus that makes sense for you. Okay, that is the only difference between the Delphi method and jury of executive opinion method, right? So there's a really nice movie that I can recommend you to watch. It's called 12 Angry Men. It's an old movie, but I really like it. It demonstrates a nice approach for implementation for the Delphi method, I believe. Um, all right, there are different types of quantitative methods, but in this course, we are going to be mostly covering the time series forecasting. Um, Given that we have the historical information, historical data, like in this case, we do have the demand for a specific product, and on the x-axis, we do have the time component. This makes it a time series model because time is a decision-making factor in our historical data, right? Because regarding time, our demand is changing. In this case, we do have a positive trend, right? As the time increases, the demand is increasing as well. Except this anomaly, this is called outlier. This point doesn't really fit into our positive trend, but we can just definitely ignore that and then pretend that the rest of the data is going to be represented by this straight positive line, right? So if we had this line, on the other hand, again, if I draw this, if we had this time versus demand, and we see this kind of behavior, right, means that we have a negative trend in our data. In other words, our demand is decreasing as time increases, right? So there are some certain patterns that we should be aware of when we look at when we plot our demand, our sales, or whatever the point of interest is across versus time. There might be some cyclical operations or behaviors like this one. It is important to us to understand whether it is cyclical or it is just purely random that the data is behaving like this. So what other patterns that you might see in the data? You might see no trend like this one in this case, right? Or you might just see a linear positive trend, okay? Or this would be a negative trend, right? This would be a negative trend. But it's important to identify that it's a linear positive or linear negative trend. We might have a nonlinear, in this case, exponential growth, right? Or we might have a nonlinear damped trend in our data. So these are certain patterns that might appear in your data sets, right? For example, let me draw another one here. If I have, sorry, this is time, and this is demand, let's say. If I have this representation here, right, it means that I still have a positive trend. This is positive because as time increases, my demand value is increasing as well. But it's also seasonal or cyclical. The terms are almost interchangeable, but there's a very tiny little difference between them. It means that my sales are increasing, my demand is increasing along with time, but it's also showing me a seasonal pattern. So this could be a new initiative, a new ice cream company that's expanding in the market. Their sales are increasing during summertime and decreasing during wintertime. And again, it's increasing in the summertime and decreasing in the wintertime. But over time, their sales, their demand values are increasing. So that could be one example. So the reason that we should be aware of these behaviors is because next time we would like to predict the future, we would love to use these simple behaviors in our forecasting methods. And those are going to be very handy when it comes to putting our forecasting methods together. Okay. So in the next video, I'm going to talk more about certain quantitative forecasting methods, and that would be naive forecasting method and moving average forecasting method.